Hello, everybody, and thank you for coming to the session. The session is called What I Learned About OpenJDK as a Docs Writer. It will be presented by Frank Delporte, my friend and colleague. My name is Geert-Jan. I'm from Azul, and I'm also from the Friends of OpenJDK project and from Apache NetBeans. But let's hand over to Frank and the talk, What I Learned About OpenJDK as a Docs Writer. If you have questions, feel free to ask them during the talk. We'll try to show them on the screen as they appear. And also there can be some discussion at the end if there are questions left to be answered. With that, over to Frank.
Okay, thank you, Geert-Jan, for the introduction. Yes, indeed, this session, what I learned about OpenJDK. I'm Frank Delporte. You can find me on Mastodon on the fujay.social instance, and you can also find me on Webtechy, which is my personal blog. All the links of this presentation can already be found on that website. So webtechy.be, the latest post is a list with all the links of this presentation. So if you want to dive deeper into one of these topics, you can find it here. Some people may also know me as Java on Raspberry Pi. That's my pet project, and I will tell you a bit more about that. But what's the things I want to share in this presentation? It's quite a lot, so let's go quickly through them. You will understand this slide better, the difference between JDK, GRE, and JVM. I will definitely also talk about the OpenJDK project and its sources, also part of this presentation. Then the whole thing about these versions, what's happening with all these Java versions, and inside those versions, what can we learn about databases inside the OpenJDK project? Garbage collectors, quite a big topic. And I have something also about warm-up of applications. So you see quite some content I try to ramp into 1 hour, but first some history. So I'm Frank Delporte. I started programming in the 80s. This was my first computer. I think most people of my generation will recognize it. A fantastic machine. It got me introduced into software, but more importantly, it also got me interested in the combination of software and hardware, as it allowed me to control my Lego trains. So already at that time, I had a computer which allowed me to interact with the physical world and have an interaction with electronic components through software, so combining software and hardware. It got me interested in technology, but I also had an interest in media, so I actually graduated as a film and video engineer. In the time that it was all analog video, internet was not yet there. There were some first evolutions going there. So I went through the whole evolution of analog video to digital video, putting it on a CD-ROM, on DVD, websites. Then websites became not so static anymore, and you had Flash. And you see, at some point, over 10 years ago, I got into contact with Java and JavaFX. And since then, that has been my main language, the language I love, because everything I try to do, I can do it with Java and JavaFX. So that's really my playground. A few years ago, I started a pet project to go back to that initial love for software and hardware and combine them. And I found the Pi4J project, which exactly allows you to do that, control electronics on a Raspberry Pi with Java. I've written a book about it and also written a lot of content about it. And that's how I started the combination of programming and writing, and how I became a part of the Azul team 2 years ago as one of the doc writers. So I am working on the documentation for the products of Azul. You may know us probably from Azul Zulu, is one of the Java distributions. You can also know us from Azul Prime, which is the platform for heavy applications with a low latency, heavy load, where you want to go fast and go very fast and stay fast. And we also have a lot of tools around Java. Azul is really a Java-focused company. If you want to know more about the state of Java, how many Java is used in companies, which versions, what kind of applications, then definitely check out the State of Java report, which is available on the Azul website. But to conclude my introduction, I am a Java developer, although lately I've been focusing on documentation. But by joining Azul, I became part of the team who creates Java. A lot of Azul engineers have a history at Sun and Oracle, and they are also part of groups of developers who work together on OpenJDK and the Java project. And by joining this company, I gained a lot of insights into the OpenJDK project and how Java evolves. I've written a lot of documentation and blogs about it. And from those blogs, I want to share you what I learned in the last 2 years. I also became, by coincidence, a Java champion last year, probably because of the content I have been writing the last years and what I've been telling at conferences. So I'm very honored that I am a Java champion and also can be part of this conference now. So some things I learned. Maybe the most important thing I want to share today is install SDKman. If you never heard of the tool, check it out today. It allows you to switch between Java versions, but also install Java-related applications like Maven, for instance. And it allows you to switch between Java versions very easily. So, for instance, for me as a docs writer, I sometimes have to go back to an older version of Java. With a one-line command, I can do that very easily with SDKman. So check it out. You will also see in the next slides that I have some screenshots of versions that I listed with SDKman. Before we dive into the details, we have to make a few things clear, and that is the difference between Java and OpenJDK. Java is a trademark. It's a name. It's owned by Oracle. It is a name for the programming language, and it also defines the Java Technology Compatibility Kit, TCK. The TCK defines what a Java runtime should be able to do. So every distribution that you get from an official supplier of the Java runtime has to comply with the Java Technology Compatibility Kit. Mouthful. So it describes how a Java function application should behave, and it ensures that you will get the same result from your Java code independent of the distribution, the runtime that you're using. Now, the OpenJDK project is actually the reference implementation of the Java platform. So it defines the programming language, it implements the programming language, it also provides the JVM, the virtual machine, and it also provides a lot of core libraries. And it is distributed under an open source license on GitHub. So you can get the whole OpenJDK project, you can find it on GitHub. And it's free to use and modify. So if you go to github.com/openjdk, you will find over 100 repositories in there. The most important ones are JDK and JFX. So JDK for the OpenJDK, JFX for JavaFX. But you also find a lot of other repositories there, like you can see at the bottom of the screenshot CRaC. I will come back to that later, but that is a fork of the JDK project, and then some additional functionality is added there as a proof of concept. But because OpenJDK lives on GitHub with the sources, that means that you can build yourself your own version. So this is a blog I already posted some years ago, and I recently redid it. So on my Raspberry Pi, I have installed Java 21 with SDKman. So I can execute any Java program on this Raspberry Pi with version 21. But I also downloaded the sources of OpenJDK repository CRaC, which is actually OpenJDK plus some additional features. I followed the README to build the whole thing and to produce me a Java executable for my Raspberry Pi based on the sources of OpenJDK. So you can do that yourself. Just follow the README. You don't have to know everything about OpenJDK or compiling Java. You just follow the README. You have to wait a little bit. I think it was over one hour, an hour and a half. And then after some time, I can again do Java version, but from this specific directory where this new version was built, and I get 22 internal. So I can already run Java 21, which will only become available in a few months. I can already build and run it on a Raspberry Pi because I've built it from the sources. So this is a fun project, a weekend project to do. Just get the sources of OpenJDK and build them yourselves. Now, the JDK is actually a big thing. It is the Java Development Kit. That means that the JDK provides you everything to build and develop Java applications. That also means that it actually has too much content or too much files in there if you just want to run Java applications. So in the past, we had the Java runtime environment, which is only the JVM, the Java virtual machine, which executes your application. So let's dive into them one by one. The Java development kit, it's the source of everything else. So every new Java version is actually a new version of the JDK, and it contains the Java virtual machine, libraries, tools, everything you need to build Java applications. Until Java 9, with each new JDK, you also had a JRE, a Java runtime environment. So that was the one you could use in production, for instance, to run your Java applications. It's smaller, so if you use it to create a Docker, then your Docker is also smaller because it only is a limited set of tools, everything you need to execute applications. Now, why are there no JREs anymore since Java 9? By the way, some distributors still make JREs like Azul, so you can still find JREs for newer versions of Java. But actually, we have an even better way to do that, and that's JLink. JLink and then even JPackage will allow you to create runtime environments specifically for your application. So you can go from over 300 megabytes of an JDK to maybe 40, 50 megabytes with only the Java libraries which are actually required by your application. So that's a Java runtime environment. Check JLink, check JPackage. They allow you to create much smaller runtime environments. And then the Java virtual machine is the executable, is Java, the Java minus version, for instance, that you're executing. So it allows to write your application once on one computer and run it anywhere on Windows, on Mac, on Linux, on different platforms. And inside the Java virtual machine, you will find the just-in-time compilation, the garbage collection, thread management, all these tools which make it for you as a developer easy to create an application. But there is a lot we should know also about versions. And then there are two important concepts. One is upgrading, the other one is updating. Updating means that you stick to a certain major version, in this case, Java 17, and you update it to the newest version that is being provided every 3 months. Upgrading is going from major versions, from 8 to 9 to 10, or you can stick to the long-term support versions, 8, 11, 17, 21, and the next one in 2 years, 1 year and a half. So these are the versions that most companies use in their production systems, so the long-term supported versions. You as a developer can already try out 22, 23, 24, so that you know what has become available as a new feature once you go to the next long-term support version. Or you can also, as a company, run these in-between versions in production and then keep upgrading them every 6 months. Now, why is an update so important? Why should you update to a newer version? And it's security. Security is a hot topic nowadays, of course, but we should stick to these updates because of security. So, for instance, it's difficult in a virtual talk to ask who is on Java 17 in your production environment. But if you are running Java 17, do you actually know which version of Java 17 that you are using? If we use SDKman to list the available 17 versions of Azul Zulu, then you see that we are already on 17.010. So there were already 10 security-related updates of Java 17. Okay, so let's jump to the latest release note. So this is January 24. We released this 13 days ago. And you see that we are here on Java version 17.010. And the important table here on this page is the common vulnerabilities and exposures. So these are security issues which were found during the previous months, which got solved and released in this version 17.010. And then you see that there are quite a few. This was one of the latest big ones. Normally we have about 4 or 5 of these security issues, and you see that there are even a few with a high score that should be addressed and fixed. But that means if you are still on 17.01, then you missed 9 of these updates, of these security updates. So following this release cycle of new versions every 3 months will keep your system up to date. Now, why should you upgrade and go into a higher version from 17 to 18 to 19 to 20, now 21 that we had since September? Those are performance improvements and new features. Since Java 10, we have the 6-month release cycle. So twice a year, a new version of Java is released. So this year, we will have 22 in March, 23 in September. What happens between those versions? What happens from 20 to 21? Everything that is happening in these new major versions is based on JEPs, JDK enhancement proposals. Those are proposals to enhance OpenJDK, and they provide a roadmap to what is happening in the OpenJDK project and how Java, both the language and the runtime, keep evolving. So if you go to openjdk.org/JEPs, you will find a long list of Java enhancement proposals. Most of them are already closed, integrated into an earlier version of Java, and some of them are now being dedicated to Java 22, for instance, and so on. And you can see what will happen in the next Java versions. In September last year, we had the release of Java 21. For Fuji, I had a podcast where we discussed all the new JEPs that are included in Java 21. And then you see, for instance, the finalized new features. These are JEP numbers. These are the JEP numbers, so you can find them on the OpenJDK website. So 1, 2, 3, 4, 5, 6, 7, 8 JEPs were finalized and integrated in Java 21. A few important ones, like virtual threads, was finalized, and others. So this is the whole list. Listen to the podcast, and you can read a lot about it on Fuji also. But what's also important is that with each new version of Java, certain features are included but not finalized. So incubator and preview features, they are called. For instance, one that I find important is instance main methods. So it's a way to start Java simpler, to explain it to new Java developers without the need to explain private, public, static, void, main. That whole thing got simplified to just a main method. And you don't need a class even anymore. But there are others. So what happens with these JEPs? Java is a very stable environment. But if the developers of Java are not sure that the feature is finished or that it's already covering all the requirements and the use cases, they make it a preview feature. It's not enabled by default in OpenJDK, so you cannot execute an application and use these features. You have to add a flag to enable them, also in your IDE, in your development process. And then you can experiment with this. And actually, this has proven to be a very good way to get feedback from the community. Is this exactly what we need? Is this the improvement that we wanted? For instance, the instance main methods in 22 will get a second preview because it was not exactly what the community wanted from this. And then hopefully in 23, it will be finalized and become part of the OpenJDK project and not longer as a preview. So each new version of OpenJDK of Java has a list of these finalized and incubator and preview features. And of course, bug fixes. Now, where do you get your Java runtime? Most people say, yeah, it's OpenJDK. I'm executing OpenJDK, but actually you cannot OpenJDK because that's a GitHub project where the sources live. It's not a runtime. It's not something you run on your PC. Indeed, in a Maven project, as a developer, how to upgrade from 11 to 17. In your Maven project, you can define your Java version. And also in your IDE, you can select which Java version you want to execute your application with. Now, where do you get the Java runtime? Again, SDKman, give me all the Java, all the versions 1709. And then you see that we have a list of distributors who provide this version of the OpenJDK project. So you have from Amazon, from Graal, Liberica, Belsoft, you have Microsoft, you have Temurin, you have Azul Zulu. So you have different distributions. And then even some distributions like Liberica and Zulu, which also include OpenJFX. So you have JavaFX runtime dependency also included in that OpenJDK. So there are a lot of distributors who provide runtimes based on the OpenJDK project, and you can choose between them. Some have support contracts that they provide, some have other licenses. It all depends on its software. Everything depends on something. It depends on your use case, on the kind of support you want, and that kind of things you have to consider. If you have questions about this, you can find this free ebook, OpenJDK Migration for Dummies, on the Azul website. It is written by Simon Ritter, who is the deputy CTO of Azul. So yes, the book is written by someone from Azul, but no, it's not an Azul sales book. So it's really generic information about OpenJDK and runtimes, and which runtimes you should consider depending on your use case. Now, why is it also important to keep your runtime up to date? And this is a nice thing I discovered while writing documentation for the new version of Azul Zulu, is inside the OpenJDK project, there is a time zone database. You can check that if you execute JShell. If you don't know JShell, please try it out. It comes with your OpenJDK. JShell is a terminal to execute Java code immediately. So it's a very easy tool to test some things. Like, for instance, if I import the package with the zone ID, I can just execute this command, and then it gives me that there are 603 time zones defined in OpenJDK in the Java runtime. So give me all the time zones. It's a long list. I've truncated it, but you see, it's all the countries, all the time zones, everything is in there. Now, what is included with this information? And that's a very nice thing to do. Again, a weekend project. Go to the sources of OpenJDK, click through in the project, and you will find a directory with time zone data. And for instance, in the Europe file, I'm from Belgium, so I was looking for information about Belgium. This is actually a history book. So you see, with some commands, the community has extended this time zone data and have given information about time zones and where it's based on. And here you have some rules which define time zone data, daylight savings, that kind of stuff. So OpenJDK is not only a source project for Java, but it's also a history book. I found this quite interesting to find this kind of information within that GitHub project. And the time zone is actually based on the IANA time zone database. So with each new update every 3 months, In the documentation, you will find which time zone is used as a base for this release. Now, where does this come from? It's actually from the IANA website. Again, it's a community project to keep one database, to make one database containing all this information and make it available for all projects. But it's not only time zone data. So if you look into the JDK issues that get solved with each new version, these were a few that got into January 2023 release, then you see that a JDK issue was created to change the currency for Croatia. Now, what is the impact of that? We can very easily test that out again with JShell. So when running JShell from OpenJDK 1901, that's the version before January 2023, and you create a currency for the country Croatia, which has the code HR, and you ask for the display name of the currency, you get the Croatian kuna. Now, without changing anything of this code, so this stays all the same, the only change is here, the runtime. So with SDKman, I said SDK use Java 1902. If I do exactly the same thing for Croatia, I get the euro. So this is very important to keep in mind. If you have a shop, for instance, where you show currencies based on countries, you don't need to program this because OpenJDK knows this. But it is important to then update your system, keep your system up to date with the latest releases, as OpenJDK handles this for you. A side effect, if you have a unit test where you test the currency for certain countries, your unit test can start to fail just because you changed your Java version. That can also happen. So this kind of information, time zones, daylight savings, currencies, is all part of OpenJDK, and your Java runtime, if you use the latest version, will give you the right values. Okay, another topic, garbage collection. Actually, this was the first blog I've written for the azul.com website, and I have been struggling with it, I have to be honest. I did Java development for over 10 years before I joined Azul, but I never needed to worry about the garbage collector. What is it doing and why is it working as it is working? Because in the daily use, as for most Java developers, you write an application and the runtime takes care of memory usage and garbage collection, and you only need to worry about it in some specific use cases, in big environments, even heavy loaded applications. So what is the role of the garbage collector? The focus of it is that you as a Java developer doesn't need to worry about memory. It's not like C++ where you have to allocate memory and clean it up again, because the garbage collector does it for you. You can focus on the business logic. You fix the problem that you have to fix for your customer or your company. And the garbage collector will make sure that you have the memory available for it. And if memory is not used anymore, that it cleans up. Now, the garbage collector is a pretty complex system working in different stages, marking the memory that's no longer used. It traces it, then it finds some dead leaves, a whole process, sweeping memory, compacting it, copying it, moving it, defragmenting it, if you have a bit of knowledge of older computers. And then you even have different types of garbage collectors with single pass and multi-pass, serial doing one thing at the same time, or parallel doing multiple garbage collectors at the same time. Stop the world versus concurrent. Does your application need to stop to do the garbage collector and then continue, or will your garbage collector run at the same time as your own application? And then generational versus non-generational garbage collectors. So if you use a new method which has some variables, then probably they are young generation. They die very fast. You just use them in a method for a short time and then they can already be cleaned up. Only variables which are living at the highest level of your application need to be stored for a long time. So they are old generation, and they can move to a separate part of the memory space. And the young generation is the thing that gets cleaned up a whole time. So those are all principles used in garbage collectors. And I have to say garbage collectors because there are a long list of them. And they all have a bit of the same problem. Maybe you have been in project management before. And in project management, there is a principle 2 out of 3. A project can go fast, it can be of good quality, and it can be of low cost. But you will never be able to combine all 3 of them. You cannot create a project very fast with high quality at a low cost. And a bit the same thing happens with memory and garbage collectors. You cannot have very low latency and very high throughput and low resource usage. So you have to choose which of these are important to you and pick 2 of them. Luckily, there's one exception there, and that's another garbage collector, but we'll come to that. So types of garbage collectors, the serial and the parallel, probably the oldest. You have concurrent mark and sweep, so you have other ones. And then there's a special one, the C4, the continuously concurrent compacting collector. I have to read it, I cannot remember it. Is, for instance, a garbage collector, which is developed by Azul and is only available in an Azul Prime, so in a licensed model. So there you see that there can be different versions of runtimes with different capabilities, but still compliant to the TCK. So each runtime has to be compliant to the TCK. So Azure Prime is, of course, compliant to the specification of Java. It will produce the same result as you expect from any runtime, but how it works, how the garbage collector works, is completely different to other ones. Now, which one should you use? Again, it depends. It's software. For some kind of applications where the throughput is not that important, you can have a cheaper system with less resources, less CPU, less memory, and use one of the serial or parallel garbage collector, for instance. Or if you have a high-end machine where you have a lot of CPU, where you can run the garbage collector at the same time as your application, there are other ones. So each Java version has a default garbage collector, but still you have flags to define which garbage collector you want to use. Which one is the best? Again, it's something you need to research and to try out in your application, in your production environment. Warm-up, another topic I was not aware of as a Java developer. This one I knew. You write your Java code. The Java compiler, Java-C, makes a class file out of it, produces bytecode. Now, what is the goal of this bytecode? This file is actually the file which can be executed anywhere. The Java runtime understands bytecode and can execute it. So, independent if you run your application on Windows, on Linux, on macOS, on no matter which platform, there is a Java runtime for it. It can take the bytecode, execute it, and you get the result you expect. You as a developer are working here. You're creating Java files and building them. But this bytecode, these class files, have one main disadvantage. So the advantage is they can run anywhere. The disadvantage, they are not optimized for the platform they are running on. But we have the JIT compiler in Java. And the JIT compiler is actually an amazing piece of technology because what it actually does, so as soon as your Java application has started, it has loaded your class files and it starts executing your files. That's the yellow zone here. But it's not as performant as it can be for your platform. But as soon as your application starts running, Java will check which of the methods are used the most. And as soon as a certain threshold is reached, it will start compiling that code into native code specifically for the platform it's running on. And that's where you enter the green zone and your application becomes much more performant. The green part also monitors how your code is being executed, which parts of the code are really needed. And then it does again a compilation, which takes a bit more time, but produces even better native code. That's the blue zone. And then you see that your application speeds up and gets better and better in performing its tasks. Sometimes it has assumed that you will use the code in a certain way. It was wrong, so it will decompile it again and make new native code. But that's the main advantage of JIT. It makes sure that your application performs at its best level that it can for a certain platform by producing native code for that platform, taking into account how the code is being used. But that means that each time you start a Java application, you go through this cycle. Each time your code has to be analyzed and converted to native code. So there is some time needed for each application to get to its best level. Also, if you scale up, if you add extra instances of the same application, again, they need to learn and go through this curve. So this is the same curve, but then as a circle. So you start with your interpreted code slow, the hotspots are found, the code which is executed the most, it's compiled as fast as possible with low optimization. Then it profiles how is the code being used. For instance, if you have a switch case with 5 cases and 2 of them are never used, they will not be compiled to native code and be replaced by some exception handler. So the code can be compiled to the best possible level. And if then turns out that one of those cases which was left out is still needed, it gets de-optimized and goes through the whole cycle again, but then you will have, again, the best optimized code for the certain use case you have. So a total warm-up process is actually the start of Java, the executable Java. Then it needs to load your classes. That's the second part. And then it can kick off the main method. And from there on, you have the actual warm-up because the code that you wrote gets improved and compiled into native code. So one solution there is ahead of time compilation. That means that you move the compilation to native code to your build system. So on your build system, you create a native application for the platform or platforms where you want to run your application. So you need to do this for all the platforms. And then you're removing some of the barriers that we have with the JIT. What I learned, I went to several conferences where Azul was also present with the booth. We talked to several developers. And there I learned that ahead of time is very nice. It starts up very fast. It uses less memory. But still, they were not happy with the performance of the application because they lost the JIT. The application was not capable anymore to adapting to specific use cases. If your code today only needs 3 or 5 of these switch cases, but tomorrow needs all 5 of them, because the classes are still there with the JIT, it can recompile it to native code, matching the use case of that day. If you have a new use case, you have a new item in your shop or a new discount action that needs to be handled. So your code will adapt to that use case. And that's not possible with ahead of time. Ahead of time loses the capability of modifying itself, modifying its native code to the exact use case of that day, of that moment. So that's again a blog I wrote for the Azul website where ahead of time and JIT are compared, also with a link to the talk of Simon Ritter, where he explains this more in detail. So with Azul, we were looking for a solution to start up an application here so that we can start a second, third, or a restart of an application at this level. It is warmed up, everything is stored, which was happening before, and we can just restart from the best state that's possible. We have a solution in Azul Prime, that's the licensed version of the OpenJDK build that we provide. It's called Ready Now, that can do it. But we were looking for a solution that can also be used in infotainment system, navigation system, IoT gateways, embedded platforms even. The certain brands, of course, have several Java licenses. For instance, for the infotainment system, you want to start your infotainment system from the second you start your car, it should be available. So we were looking for a solution how we could provide that in such kind of environments. A disclaimer for the next slide. If I talk about CRaC, I'm talking about coordinated restore at checkpoint. I had some very weird conversations lately where people were wondering what I meant with distributing CRaC and using CRaC. It's this CRaC that I'm talking about. So CRaC, every word counts. It means that a running application, that you can create a checkpoint out of it. It also means that the checkpoint can be used to restart an application. And the coordinated means that there is an API that you can tell your application that the checkpoint will be created so that certain things can be done in your application or that restore has happened. Why is this important? For CRaC to work perfectly, you want to close database connections, file connections, sockets before you create a checkpoint. You don't want open files or open connections or open sockets when you restore your application, because that will fail if you move it to another system or later on the same system want to restore your application. So the coordination is also very important here. It's also an example why not all distributions of OpenJDK are the same. For instance, if you want a JDK with CRaC, you can get it for Linux with versions 17 or 21 of Zulu, but you have to select it on the download site of Azul because it's not yet included in OpenJDK itself. So it's really a separate fork, if you want to call it like that, where CRaC is implemented into the OpenJDK project. Now, we announced CRaC last year with some pretty impressive numbers. So a Spring Boot application, which takes 4 seconds on the test platform that we were using, only took 38 milliseconds to start with CRaC. So that means that you start your Spring Boot application once, you give it some load, that it warms up, you run it for 30 minutes, for instance, then you create a checkpoint, and that checkpoint is then be used later to start new instances, extra instances, and there you have a very fast startup. Now, because I am the Java on Raspberry Pi guy, I immediately got a question, can I do this on a Raspberry Pi? A long story short, first, no, it didn't work. It actually revealed how this is done because it needs CRIU, which is part of the Linux kernel. And it was not included in the build of Raspberry Pi at that time. I will go through this. I created a ticket, and now it is indeed, as you can see here, checkpoint restore is included in the latest builds of Raspberry Pi operating system because they introduced a new board and they wanted a new version of Debian Bookworm, which is the base. Debian is the base of the Raspberry Pi operating system. And in October, I did an update of this, and this works. I will show you in a little demo application. Now, the demo application is a CRaC example, which is using Jetty, a PostgreSQL database, and CSV files. And why CSV files? So what I've done in this demo project, you have zips with a lot of records. Records are in the form of this, just dummy data. What I wanted to illustrate with this application is that if you load such a zip file, it needs to be unzipped. Every line of the text file need to be converted into a data set and being read line by line. So this takes some time. Then I have a database connection to store the logs, how people are connecting to this application. And here you can see actually that I have some checkpoint related functions. Okay, I will not go into detail. The application, the sources are available online. You can find a link here, and also on webtechie.be I added a link. Thanks, Vincent. That's a very good remark. We use CRaC, but then I'll leave it to you to decide if it's the CRaC from Azul or the other CRaC. How do you add CRaC to a project? It's a dependency you need inside your project because CRaC only exists for Linux, and in Windows and macOS, this dependency will take sure that you can test your code and you can run it and try it out. Does it mean I can set checkpoint on runtime? I will show you how I create a checkpoint a bit later, so stay with me. So this is the only code you need. Every class which needs to do something on checkpoint has to be registered with this line. And then you have two overrides before and after. So for instance, before is closing a database connection, after restore is reopening the database connection. When you have an application which is CRaC ready, you start it as a jar file, but you need to specify the location where the checkpoint needs to be stored. It's a directory. And then in the second terminal, when the application is running, has been warmed up, you can create a checkpoint like this with J command. It will save it to that directory that you've specified here. And then at a later stage or on another machine, you can restart from the checkpoint. Now, let me just show you. This is, for instance, the demo on the Raspberry Pi. I start the application. You see, it's a Jetty application. It needs to start the web server. It takes about 5 seconds before the application is actually running. Now, as soon as it's running, I can go to localhost and I can see the list of files. I can pick one of these files. It will unzip that file, convert it line by line, and give back the first 100 results. You see, this goes very fast for the small ones that go a bit faster and further. If you're asking for the big zips, then it's already 7 seconds. And the biggest one is about 15 or 16 seconds. It's now loading it. You see, it takes a lot of time. So it's unzipping it, loading into memory. So now we have all those records in memory, 16 seconds. That means that as soon as it's in memory, I don't need to unzip it anymore. And I get the same call returns now in 8 milliseconds. Very fast. That's Java. It's in memory. It's very fast. Can handle any request very fast. Okay. A bit further, in the second terminal, we're now going to create a checkpoint. You see this directory is still empty. In this terminal, we have J command, create me a checkpoint. You see some logging appear here that the checkpoint is being created. And as soon as the checkpoint is ready, you will see that the application is actually killed. So it stops the application. You need to remember that creating a checkpoint is actually also stopping the application if the checkpoint was created successfully. So you see, it's not running anymore. Now we have the checkpoint, and now you see it has restarted it. Did you see it, how fast it was? Keep an eye on here. Check. Within milliseconds, the application has restarted. Yes, also on a Raspberry Pi, a very cheap computer. Remember that? And now we can ask the same big file again. Everything was reloaded into memory. You see from the first request on, we have a reply in 6 milliseconds. So we skipped the whole 16-second loading the zip, unzipping it, and parsing it into objects. Okay. What's the current state of the CRaC project? Again, it's a nice example of how OpenJDK works. It is at this moment a research project. So you can find it on openjdk.org/project/CRaC. So that's where it lives. We hope to create JEPs out of this. That means that it becomes a Java enhancement proposal to be added to OpenJDK. But you also have Project Leiden, which has a bit of the same goal. So maybe one day they will join or merge or come together at some point. But you can already use CRaC. You've seen that we have runtimes of Azul Zulu. You can find a lot of documentation about it on our docs website. It's also the system that has been integrated by AWS into their Lambda snapshot. So if you upload a new jar to that system, they will actually already execute your application and take a snapshot out of it and then use that snapshot to start new Lambdas. It's also supported by Macronaut, Quarkus, and Spring. We even have a new blog on FooJ.io by Gerrit Grunwald, our colleague, who was comparing Spring Boot 3.2, which has CRaC support. So here you also see which improvements each new version of Java brings. So even without changing anything in your code, but just changing the Java version where you're using to run your application gives you almost a second of startup improvement. And then you have different ways of creating a checkpoint with Spring, but you see you go from 4 seconds to 400 milliseconds or even 75 milliseconds. So you can get a lot of speed up, warm up improvements by using CRaC. A little bit of conclusion. I cannot go into each of these. Check out this blog, 9 outdated ideas about Java. Java is old. Yes, it's old. It already exists a long time, but it's definitely evolving. Every new version brings a lot of new features and improvements. You need to compile your code? No, you have JShell, you have JBang, you can execute simple Java files just with Java. Java is slow. Not Java is not slow. It can start up very fast and it will keep your code running at the most performant way in native code if you use the JIT compiler. Java is insecure. No, I've shown you. We have security updates every 3 months. A whole team of developers across companies is working together to solve every security issue that is being reported. Is Java challenging to install? No, because we have SDK and the licenses. It's an OpenJDK. It's OpenJDK, so it's free to use. It's only when you want support that you have to use specific versions or have a contract with a company, but you can run OpenJDK for free. You need a Java runtime? Not really. With JLink and JPackage, you can create your own runtime. Memory cleanup will stop your application. Yes, if you pick a garbage collector with the stop the world system, but you don't have to. You have the choice. There are different garbage collectors, and some of them can indeed run next to your application, have no impact at all on your application itself. And then some coding ideas that are totally wrong about inheritance and interfaces. Check this blog and you can read all about these new 9 myths and why they are no longer true. If you want to read more, I invite you to visit docs.azul.com. That's where I live. That's my day job. I also write a lot for FooJ.io. If you don't know it, it's the website for friends of OpenJDK managed by Geert-Jan, who did the introduction of this session. On this website, you will find at least 1 article a day about Java, Kotlin, OpenJDK, everything related to Java and the tools around it. I have my own blog posts on there, a lot about Java and Raspberry Pi, but also other topics. By the way, if you are a Java writer, please get in touch with FooJ, and you can also publish your content. We also have a podcast, and that's it for me, I think. If you want to know more, you can find me on FooJ, you can find me on docs.azul, you can find me on FooJ.social Mastodon, and I have an interesting book that you can even buy. That was my story. I know it's a lot of information. I invite you to webtechy.be. Here you can find all the links of this presentation and a lot to digest further, dive into the topics, a lot you can learn, and a lot I hope you will learn and enjoy. Thank you. Geert-Jan, do we have specific questions?
There have been a bunch of questions and that you've responded to. A lot of greetings from people around the world. So a lot of happy people with your session. Thank you so much. Oh, look at that, Johan Hutting. And hello to me. And there's a lot of people to
thanks for joining this session.
To say something. Yes. Thank you, everybody, so much for joining. And this is has been streamed, of course, and it's on YouTube. You can watch it again. Thank you so much, Frank, for sharing all your learnings from being a docs writer. It's been a great session. Thank you very much. And thank you, everyone, for joining it. Thank you. Goodbye.
Thank you.